Recording in progress.
Okay, so Jasmine, Annie, today let's learn section 3, 1.3, elimination. So remember last time we learned substitution. Substitution, you know that means you represent one variable, use another variable. Then you plug in the expression of that variable to another equation, make that equation only related to one variable, then solve that equation, then plug back. Okay, today the elimination, that means you combine the two equations together, make a new equation. This new equation only related one variable, okay, or fewer variable. So you can see here, elimination, it's a process of solving or simplifying a system of equations by combining the equations to produce new equations with fewer variables. So here is an example. Suppose we solve these two equations, x plus 2y equals 7 and x minus y equals 4. When we add the twice of the second equation to the first, so that means you do this, you times 2 to the second equation, you times 2 to the both side of second equation, then you will get, let me write here, that will be 2x minus 2y equals 8. Then you add these two equations together, then you get 3x, the plus 2y minus 2y cancel out, you get this one equals 15. So then both sides divided by 3, you get x equals 5. After you get x equals 5, then you can plug into any of these two equations to find a y. Okay, but then you still need to try to pick the easier equation. Here, this one is a little bit easier because all the coefficients either 1 or negative 1. So you got a 5 minus y equals 4. So then you can write this one 5 minus 4 equals y, right? First, both sides plus y. You got a 5 equals 4 plus y. Then both sides minus 4. You got a y equals 5 minus 4. This one equals 1. So therefore, we got a y equals 1, x equals 5. Okay? So you can check. X equals 5. 5 plus 2 times 1, that's 2. 5 plus 2, that's equals 7. So this equation also satisfied. This one, x equals 5 minus 1, you get a 4. So this one also satisfied. So this process called elimination. right? So we did not represent like x or y from one equation when then we plug into that another equation. That process called a substitution. Here we combine these two equations together, we get a new equation only related to the one variable x. Okay, you can also try to cancel out x to get a y. Okay, then you can solve y first, then to after you get a y, then plug into any of these two equations to find x. Okay, so see here, let me ask you a question. If we try to cancel out x, what number we need multiplying to the second equation can make us cancel out the variable x, only have variable y left? So Jasmine, can you tell me, answer this question? Jasmine?
Wait, can you repeat that?
Yeah, you can see when we solve this equation, what I show you here with times 2 to the both side of second equation, right? So we get this one's 2x minus 2y equals 8. Then we add these two equations together, we get 3x equals 15, right? By this way, we cancel out the y. We times 2 to the both side of second equation. So now my question is, we try to cancel out x. Can you tell me what is the number we need to multiply to the second equation can make us cancel out the variable x?
1.
You said times 1?
Yeah.
If times 1, okay, so then this one will be x minus y equals 4. So then how we can cancel out x?
Subtract.
So you do first equation minus second equation. So can you tell me what is the result after you do the subtract?
3y is equal to 3.
Okay, very good. Then both sides divided by 3, you got y equals 1. Okay, very good. So therefore, here cancel out x also very convenient. Times 1, that means you don't need do that process. Just move that here, use first equation minus second equation. You got 3y equals 3. So then y equals 1. Then plug back to this or this equation. Then you can get, suppose plug to here, you get x plus 2 equals 7. So you get x equals 5. Okay, very good. So have you got it? Okay, so now let's do this example 1.10. Ellie, can you help me read 1.10? Ellie, are you there? Okay, so Jasmine, can you read this problem?
In this problem, we solve the following system of linear equations. 2x plus 3y is equal to 35. 13x minus 6y is equal to negative 2. A. Multiply the first equation by a constant to produce an equation whose y coefficient is the opposite of the y coefficient in the second equation. B. Add your result from A to the second equation to produce a new equation. C. Solve the original system of equations.
Okay, can you solve part A first? So multiply the first equation by a constant to produce an equation whose y coefficient is the opposite of the y coefficient in the second equation. So both sides times 2? Okay, after you times 2, what is
4x
you got a 4x
plus 6y is equal to 70.
plus 6y equals 70. Okay. Yes, very good. This you solve the A.
You add it and you get 17x is equal
17x equals
68.
68. Okay. Then both sides divided by 17. So
4.
X equals 4. Very good. Very good. So you got X equals 4, right? Then you can plug in this number to, let's say, plug to the first equation. So then you got a 2 times 4 plus 3y equals 35. So this is 8, this is 35, not 37. 35. So you got a 8 plus 3y equals 35. So then you got a 3y equals 27. So then both sides divided by 3, you got a y equals 9. Okay, so then you can plug in these two numbers to the second equation to check 13 times 4 minus 6 times 9. You check if this one equals negative 2. So that's 52 minus 54. So therefore this one equals negative 2. So that means second equation also satisfied. When we plug in this one to the first equation, we get a y equals 9. So that means we also verified the first equation is satisfied. So therefore, we verified the solution of this equation, that's x equals 4, y equals 9. That's correct. Very good. Okay, so now let's go to 1.11. Jasmine, can you read this 1.11?
The sum of 3 numbers is 12. The third number is 2 less than the sum of the second number, and 3 times the first number. 5 times the first number is equal to the sum of the second number and the third number. Find the numbers.
I'll give you 3 minutes. Can you solve this equation? Solve this problem. Say they give you the 3 numbers. They said the sum of these 3 numbers is 12. So you can set this 3 numbers, suppose you can use any letter, okay? Suppose that's x, y, and z. Then sum of this number equals 12. So that means you can get equation x plus y plus z equals 12. Okay? So third number is 2 less than the sum of second number and 3 times the first number. So now let's say third number, that's z, right? Z equals is 2 less than sum of the second number and 3 times the first number. So that means z equals let's say sum of the second number, that's y, and 3 times of the first number, that's 3x, and is 2 less, so that means this one then minus 2, right? Z will equals y plus 3x minus 2. So that's 2 less than the sum of the second number and the 3 times the first number. So 5 times the first number is equal to the sum of second and third number. So first number, that's x. 5 times of the first number, so that's 5x equals sum of the second one and the third one. Okay, you got a 5x equals y plus z. Then they ask you to find these 3 numbers, right? So let's say to solve this equation here, this equation, we have three variables, we have three equations, right? So if we plug in this z to this first equation and the third one, then we can reduce this equation from three variables to the two variables, right? We can do this. You can get an x plus y, then plus y plus 3x minus 2. You got this one equals 12. So we can simplify this. You got a 4x plus 2y equals 14. Both sides plus 2. Then both sides divided by 2. Got 2x plus y equals 7. So this is the first equation. After simplify, we get this. Now you plug z to here. You get a 5x equals y plus 3x minus 2. So then you simplify 5x minus 3x, you get 2x. Y plus y, that's 2y, so minus 2y. Then this one equals negative 2. So both are divided by 2. You got to actually here probably don't need it. Yeah, you can divide it by 2. You got x minus y equals negative 1. Okay, this is third equation after simplify. So then, we reduce this equation with three variables to the two variables. So now you only need to solve these two equations. To solve this one, you say we can use elimination. You just add these two equations together. You get a 3x equals 6. Then both sides divided by 3. You get x equals 2. This is an x. After you get an x, you can plug in to any of these two equations to find a y. So we can plug into like first equation. You get that will be 4 plus y equals 7. So therefore we get a y equals 3. Okay, y equals 3. After you get a y equals 3, then you can plug into this equation to find a z. So that will be 3 plus 3 times 2, that's 6 minus 2. So you got this one equals 7, right? So you got x equals 2, y equals 3, z equals 7. Now you need to go back to verify. Okay, now let's first sum of these three numbers. That's 2 plus 3, that's 5, 5 plus 7, that's 12. So that means first the equation is verified. Then the second equation, that's third number equals sum of the second one and 3 times of third one minus 2. So now let's say y, that's 3. 3 plus 6, that's 9. Then minus 2, that's 7. So that's correct. Second equation also verified. Third one, y plus z equals 5x. So y, that's 3. Z, that's 7. That's add together, that's 10. That's right side. Left side, that's 5 times 2, also equals 10. So that means third equation also satisfied. Therefore, we get this numbers. They are 2, 3, and 7. Okay, so these three numbers. Okay, so Jasmine, tell me, what do you learn from this example? Can you tell me what do you learn?
It's possible to work with a system of equations even if there's 3 of them.
Yeah, so first I think you don't be scared. And when you say there's three numbers, usually you need to set the 3 variables, but read that carefully. First, probably you need to read at least 2 or 3 times. Very careful what did they learn. So this second sentence, it's very confused, okay? If you don't read this carefully, it's very easy to make mistake. After you read and understand this problem, then you follow the steps. First, set the variables. Okay, so this is very straightforward. Set 3 variables. You can use any letters, like usually we can use X, Y, Z. You can also use like A, B, C, W, U, V, like that. The letters does not matter. Then, after you set the 3 variables, you have to set up 3 equations. Otherwise, if you only set 2 equations, that means you will have maybe infinity solutions. That's number of equations is not good enough to solve these 3 variables. Okay, then you just follow this statement. Say first one, that's very straightforward. Sum of these 3 numbers is 12, so x plus y plus z equals 12. Second one is hard. So third number, that's z, is 2 less than sum of the second number and the 3 times the first number. So 2 less, so that means this number is smaller than the y plus 3x. That's 2 less, so minus 2 will equal this z. And the third one, it's easy. 5 times the first number is equal to sum of the second and third number. So that's first number is x. 5 times x equals y plus z. Okay? So then, after you got this 3 equation, you need to find the best strategy to solve this one. Definitely, you need to reduce the variables. The easiest way to reduce variable here, that's reduce z, eliminate z. So because we already have the expression for z, so if you plug z to first equation and the third one, then you make these 2 equations only related to x and y, like here. Then solve this equation. You also have 2 ways, right? You can use substitution. You can also use elimination. Using elimination, you just add these 2 equations together. You immediately cancel the y variable. Then you get this equation only related to x. Then solve x. Then plug back to any of these 2 equations to get a y. After that, you plug back to here to get a z. Okay, this is very clearly. Now let's see 1.12. So can you help me read 1.12? Just me?
Find all ordered pairs x, y that satisfy the following system of equations.
Okay, I'll give you 3 minutes. Can you solve this equation? They ask you to find all ordered pair x, y that satisfy the following system of equations. This equation looks hard, but actually it's very easy if you find the right way to solve it. You see, this section, what we learned, that's elimination, right? Ellie, are you there? So Jasmine, do you have any idea to solve this problem?
You could add.
Yes, that's the best
then
way.
2x squared is equal to 162.
Yes.
And then you divide both sides by 2 and you get x squared is equal to 81 and then square root and then x is equal to 9.
Only 9?
And negative 9.
Yeah. Say if the power is 2, that means usually this equation will have two solutions. So plus minus 9. Okay. You need to pay attention to this. Okay. When the order is 2, that means this equation usually will have two solutions. If the order is 3, that means this equation usually will have three solutions. Okay. Then after you get x equals plus minus 9, then you can plug in this one to, you can also do this. Plug into first equation or second equation. Now let's plug into the second one. So you got a x squared, that's 81. Then minus, suppose first x equals positive 9. Okay, 9 times y, that's equals 36. So you get 9y equals 45. So both sides divided by 9, you get y equals 5, right? If x equals 9, you get y equals 5, okay? Now let's suppose x equals negative 9. So then you got the first term, that's still 81. Then when x equals negative 9, here that will be plus 9y will equal 36. So you got 9y equals negative 45. So therefore y equals negative 5. So then that means when x equals negative 9, then y will equals negative 5. Okay? So then now let's plug in this to the first equation. Check if that also satisfies the first equation. So x squared, x equals negative or positive 9, x squared, that will be 81. So if x is positive 9, y will equals negative, y will equals positive 5. So 45, you got this one equals 126. Okay, so that means this one satisfied. Now another case, that means if x equals negative 9, negative 9, y will equals negative 5. So x times y still will be positive 45. So 81 plus 45, that still equals 126. Okay, so that means these two solutions are all satisfy this equation. Okay, we get two set of solutions. The reason is this one is a second order. You know, later, I think in the we did not prove that, but usually this is called algebra basic theorem for any equation. Okay, suppose we write this an x power n plus an minus 1 times x power n minus 1 to a0 equals 0. For this general equation, general speaking, this equation will have n solutions. Okay, if this one's 2, that means this equation will have 2 solutions. If this one equals 3, that this equation will have 3 solutions. So here we have this one's 2. So that means this system equation will have 2 solutions. So here you can see exactly they have 2 solutions. So when you solve this kind of equation, you need to really be careful. Okay, not of students like you see here, you said okay, x equals 9. Actually, that's not good enough. You actually is -9 still also another solution. Okay. Now let's say 1.13. Jasmine, can you help me read this problem?
Consider the following system of equations. xy squared is equal to 10 to the 8th power. X cubed over y is equal to 10 to the 10th power. A. Find positive integers a and b such that the simplification of xy squared to the a
Power
times
A.
what?
Yeah, that's power.
X cubed over y to the b power has only one variable. Solve the given system of equations.
Okay, I give you 3 minutes. Try to solve this one. This one's a little bit hard. Okay, you have this x times y squared equals 10 power 8, and x power 3 over y equals 10 power 10. Now they ask you to find the positive integer a and b such that simplification of this has only one variable. So first, you need to simplify this. Okay, you can write this one equals x power a times y power 2a. Okay, after we use a distribution for the power row, get this. This second fraction, after we use the distribution row, get a x power 3 times b, and the y that's power negative b. Okay, then you simplify the term of x. Because their base is same, then we can add their power together. I got a x power a plus 3b. Okay, this is the power for x. Then the power for y, that will be 2a minus b. Okay, then you say they said after you simplify, this one only has one variable, so that means a plus 3b, either this one equals 0, okay, or 2a minus b equals 0, okay. Now they also give you, say, this one equals 10 power 8. So another way we can write this one is 10 power 8 times 8, that's 10 power 8 times 8, right? Because this one equals 10 power 8, then power 8, so that's equals 10 power 8a. Then this one, that's 10 power 10, then power b, so that got this one 10 power 10 times b. So then we can merge these two terms together because they all have the same base 10. So this one equals 8a plus 10b. Okay, got this. So now let's say They ask you to find the positive integer a and b such that the simplification of this has only one variable. Okay, so now let's see what is a and b can make this one equal 0 or this one equal 0. So now let's say if this one equals 0, if this one equals 0, then we can get a will equals negative 3b, right? Then you get negative 3b, right? And let's say you get a equals negative 3b. If a equals negative 3b, so what is the information we can get? Let's see here. If this one equals 10 power 8, this one equals 10 power 10, okay. If we use this one, this one divide this, what happened? So we can probably solve x and y here. Let's say here, if we use the second equation divided the first one, then get the x squared, then that will be times y power, let's see, do we need to do this? Find the positive integer a and b such that this simplification has only one variable. So when we write this one, we get this one's a power this, and x power this, and y power this. So if only have one variable, so that means it's the power of x or power of y will equal 0. From the power of x equals 0, then we got this. Now is we got this. From this one, then we get b will equals 2a. But then they ask us to find the positive integers. So now let's see here. If this one equals 10 power 8 and this one equals 10 power 10, then we got this actually will equals 10 power 8a plus 10b. Okay, so then 10 we can write only can separate, that's 2 and 5. So this power 2 power will still be here, 8a plus 10b. 5 also have 8a plus 10b, right? So you can see this, okay, x definitely, x either equals 2, y equals 5. Now let's compare this one equals this, and this one equals this. Now let's see. If this one equals this, what we can get? We can get, and also, let's say if this one equals 0, and we got another one, this one equals this. And we got this one equals this. That will be 7a 9b. That's Not right. 6A, 9B. Looks this one not work. Let's see. This one equals 10 power 8 and x power 3 over y equals 10 power 10. Okay. Actually, we can start from here. Because here we can write okay, let's see what we can do here. We can write 10 that's equals 2 times 5. So this is a power 8. This also power 8. Right? This x times y squared. So suppose x equals 2. No, x not equals 2. Suppose x equals 2 power 8. Then y will equals 5 power 4. Right? If they compare this, x equals 2 power 8, then y will equals 5 power 4. Then now let's check if this one satisfies here. That was 2 power 24 over 5 power 4. This one definitely is not work. This one's not work. So now let's see here. Can we solve this? Let's see. We can write this one as, oh yeah, actually we can solve this. From here we can get a y, from second equation we can get a y equals x power 3 over 10 power 10. So then we can plug to the first equation. We can get x power x times x power 3, that's x power 4. No, this one should square because it's y squared. So we can get this. Let me write we got this x times x power 3 10 power 10, then this one square equals 10 power 8. So then we can write this x power 6 then times x power 7, then this one will be 10 power 20, right? 10 power 20, then multiply this both sides. You got 10 power 20 times 10 power 8, that's 10 power 28. Okay, so then we got x should equals, because this one you can write 10 power 4 then power 7, got x equals 10 power 4. Then got a y will equals probably into here. That will be 10 power 12 over 10 power 10. So you got a y equals 10 squared. So that's 100. 10 squared. Okay, so get this. Now let's see, this time this, after you simplify, they said this only have one variable. When we simplify this, we can get this one's x power a times y 2a, then times x 3b, y negative b. So therefore, we can write this one's x power a plus 3b, and times y 2a minus b. Okay, what is a can make this one have one variable? So that means either a plus 3b equals 0. Another one is 2a minus b equals 0. Okay, so now let's see. Actually, we already solved this equation, right? We already solved this. So if this one, after you simplify, this only has one variable. Let's see here, a minus 3b equals 0. So let's see here, because x, that's 10 power 4. So you got the 10 power 4 times a plus 3b. Okay, this one at y, that's 10 power 2, that's 2 times 2a minus b. So therefore, when we simplify, we can add these two together. So that will be, say, first one, that's 4a plus 12b. So 4a times 4a plus 12b. Second one, that's 4a minus 2b, right? So then after you simplify, you got this one's 8a. Okay, that's 8a. We got this one equals 8a minus 10b. Minus 10b. That's power for this 10, right? After we simplify, we should get this. So now let's see here. If you get one power that's the one information we didn't notice this. Say this one tell you the positive integer a and b. So definitely here we can see 3 plus a plus 3b definitely cannot equal 0. Because a is positive, b is positive, how you can get this two positive, the sum of these two positive number equals 0. So this one definitely cannot be 0. So that means this one should be 0. Get 2a minus b should equal 0. So from this one, you can get b equals 2 times a. Okay? b equals 2 times a will make this one has only one variable. That only have x. Okay? So then, but after we simplify this, you can say we can get b equals 2a. So that will be 8a minus 20a. So then you got this, that's 10 power negative 12a. Okay, you got this. So then now let's see what should be a. We already got b should equals twice of a. Then this term, the y term will cancel out. You only get this one, that's x term. Let's see here. After we plug in here, we got this one equals 8a minus 10b. But b equals 2a, so that's 10a minus 20a. So that's equals 10 power negative 12a. And then a will equals what? B equals 2a. So then that means a can be any number, any positive number, but b just equals 2a. Then we'll make this one has only one variable, right? Now let's verify, see if this. We can get a that's for any positive number. X can any positive, and b equals twice of a. Okay? Suppose a equals 1, then b will equals 2. Now let's check here. If a equals 1, then this term that will be x times y squared. And b equals 2, that will be x power 6 over y power 2. So you can see we got this x power 7, right? So that's only related to one variable. Now if a equals 2, then b will equals 4. So if this one's 2, this one will be square, then the b will equals 4. So you can see this term that will be x squared, y power 4, then times x power 24, power, let's say b will equals 4, yeah. So that's x power, x power, no, this one. Yeah, I read this one wrong. So I already, so this if b equals 4, this one will be x power 3 over y, then power 4, right? So this will be x power 12 over y power 4. So multiply it together, you get x equals x power 14. So that's only related to x, right? So here we got this answer for this equation, that for this part a can be any positive number, okay? But b will equals twice of a. Then we'll make this expression only related to one variable. That variable is x, okay? Y variable will cancel out. Then solve the given equation. You know, we get x equals 10 power 4 and y equals 10 power 2, right? So what is the, I used, I just get a y equals x power 3 over 10 power 10 from this second equation. Then plug this one to the first equation. So then I got a, here that's x power 7 equals 10 power 28. So here I got x equals 10 power 4. Then plug back to here, get a y equals 10 squared. So that's 100. Okay? So Jasmine, have you understand?
I know.
Yeah, this problem is hard. Okay? First, you know, the answer for part A is not the normal answer we meet. So first, in my idea, I'm still thinking I can get a specific number for A and B. But actually, you cannot get that. See, we can only get like A, 2A, we got 2A, no. Yeah, 2A minus B equals 0. Then first, I did not notice A plus 3B. This one actually cannot equal 0 because A and B, they limited that to positive numbers. So this definitely cannot equal 0. Then that means only this one equals 0. This one is equals 0, we can get B equals 2A. But you only have this equation, but you have two variables. So how you can find A? So later, I think we cannot limit it two numbers. We can only give A, then we know B will be twice of A. So A can be any positive integer, and B will twice of A. Then you can see we verify if that's true, then this expression will always only related to variable x. The y variable will cancel out. Okay? So this problem is a hard problem. Now let's see 14. Jasmine, can you read this problem?
Find all ordered pairs x, y such that 5x squared minus 3xy is equal to 280 and 3y squared minus 5xy is equal to 56.
Okay, give you 3 minutes. Can you try to solve this problem? So say here, we still have first x, y, two variables, right? And also, this is not a linear equation because the power of x and power of y are two orders, order 2, right? So then you need to think how you can cancel out one variable. If you cannot cancel one variable, you need to think what is the trick you can use. Say for first one, I see here, because this two term has a common factor x, we can take x out. Because this one is 5x minus 3y. Then this give us 280, right? This first equation, both the left side will take common factor x out. We got this one. For this equation, we can take the y out. Then we get the, you can see we get the negative 5x plus 3y, right? That's equals 56, right? So then we can both sides times negative. So we can change this one to 5 times parentheses 5x minus 3y equals negative 56, right? We can get this. Now you can say this one and this one, they are same, right? They are same. So therefore, we can do both. This both side divided by x. So we get this equation. We can write that's 5x minus 3y equals 280 divided by x. From this equation, we can get 5x minus 3y, that's equals negative 56 divided by y. So then say they all equals 5x minus 3y, so that means these two should equal. So that means, let me write here. Now we get 280 over x will equals negative 56 over y. Right? We can get this. So then, now let's first cancel out their common factor, because I see these two numbers, at least each one is an even number, right? So both divided by 4, right? So this one got a 14. Divided by 4, this one got a 70. So each number divided by 7, this one got a 10, this one got a 2. So they divided this one, they got this one 5. Right? So then we can write this equation that will be as 5 over x equals negative 1 over y. Okay? So then you do cross multiplication. You can get x equals negative 5y. Because this one times this, you can write this negative, you can move this negative here. Move this negative to denominator, okay? X times 1, got an x. Then 5 times negative y, you get an x equals negative 5y. This is very important, okay? Use this relationship, we can cancel out one variable. We plug this one to any of these two equations. Then you can cancel out x. You can only have y left, because the coefficient of this equation is smaller than this. So that means if you plug to the second equation, that will be a little bit easier. Now let's plug to here. So you get a 3y, because you can start from here, because we already take y out, right? So you can start from here. You can get this will be y times parentheses negative 25y minus 3y equals negative 56. So negative 25y minus 3y, you get a negative 28y. Negative 28y squared equals negative 56. So both sides divided by negative 28, you get a y squared equals 2. So therefore, you get a y equals plus minus root 2. Okay? Get a y equals plus minus root 2, you plug to here. You get a x will equals negative plus 5 root 2. Okay? So then that means we have two sets of solution. Okay? When x equals root 2, y will equals negative 5 root 2. Okay? This is one set of solution. Another one, when x equals negative root 2, y will equals positive 5 root 2. Okay? This is another solution. You can plug into these two equations to check. I'm sure this one should be correct. Okay, so time's up. We can stop here. Then the homework, that will be access problem behind this section. So next time, see you next time.